Let's start by talking about the top part of this problem. So we've got, to see if this is the case, data on the top 69 money winners from the PGA Tour in 93 are examined. Average number of putts per hole for each player is used to predict their total winnings. What is, go through pieces here. What goes here? Your X. So our explanatory variable is the average putts. What is this? What's this one? Which one of these two do I use? The top one or ever? Do I use the top one or the bottom one? And that is this word does never change. That would be, I would usually talk about that number in what kind of form of a number? Percent. So I would say 8.1% what? Of the variation in, which is what? So 8.1% of the total, or of the variation in total winnings, can be explained by the least squared regression line of total winnings on putts per hole. If I would write that one all the way out. What is this one? Standard deviation of the residuals. Now, out of context, that seems like ridiculous. But in context, it makes a little bit more sense. What does that actually, so it's 2,800, we'll just go with 280,000 as far as having a conversation for it. So the 280,000 is talking about 280,000 what? How to interpret that? What is a residual? So basically, essentially, we were wrong by an average of about that much for each guess. But the amount we guessed was off by an average of $281,777 for the different predicted winnings for each player, an average. Questions on that? All right. So explanatory variable is what? Average number of putts per hole, we just talked about that. The intercept is what? They want to test the given hypothesis. The value of the test statistic for this test. What's our equation for that? In general? Over. What's this value here? I know it's long, but what's it start with? This was a negative form, something. What is beta? So this is what goes on top, which are B. This is our standard error beta. So it ends up being this divided by this, because this minus 0 divided by this. And what do we get as our answer there? Well, I could look at that problem and tell me the answer. What's the answer? Do I have to plug in any numbers? The only -1. freedom? What is my n? So what is my degrees of freedom? What does this word mean? Did this problem give us R? What does it give us? Well, how do I go from R squared to R? Square root. But the one thing you have to remember or decide on your own is what? If it's negative or positive. So you said slope is negative, which means R is also going to be negative. So what's the answer here? It's this one? Right. And then the last one gives us a confidence interval answer. Now realize usually we see confidence intervals as like number, comma, number. But this one doesn't look like that. So this just takes the value before our plus minus and then everything after the plus minus. So what's our general equation for confidence interval for slope? So my B is my slope, which we said was the negative 4 million number. Well, that should eliminate answers for you right there, so it's not these. We've just got to figure out the bottom part. So it is this plus or minus T, which I'm going to have to look up. And my standard error of beta is 1,698,371. So what did this problem not do, or this answer choice not do? It forgot T. As long as T isn't exactly 1, then it's this answer. But we could go look up, so how do I actually find T? What's my, am I doing a confidence interval or a test? So what does my interval give me? What else do I need for T? And we said that was what? If you are using your chart, we're in the column that says, okay, the top, bottom. The top is the percent, the bottom. 95% here. I'm looking for 67 over here, but 67 is not there. So the two closest ones I have are 60 and 80. Which one do I choose? Which one of these two do I choose? I'm thinking about a way to explain it. I want to be the least correct, I guess, as possible to save myself. As my ends increase, these values get closer and closer to the what? Like what's this bottom line? My z's. So as my ends get bigger, they get closer and closer to this. There's error as I go up. So which one would you choose? I haven't talked about this much in the calculator. I want everybody to do this with me, just so that you see it. So if I draw this as a 95% confidence interval, how much is in each tail? I want you to go to distribution. The second distribution. And if you go to that one, so inverse T, I'm using a T in my calculator, but I'm doing inverse because it's finding me the T value instead of me giving it. What does it ask for? So we're finding one T value, like one exact line. So I want this area to the left, which is 0.025, what is my degrees of freedom? Before I even hit enter, is this going to give me the negative one or the positive one? The negative one, because that's what I asked for. And then you could write that one as your plus minus one. If you want to use it in the calculator, do it that way instead of using a table. Second distribution. It's like second variable, or variables is a button, but it's second distribution, and then down to inverse t.
What is this?
Finding our t value, just our t star. I don't have it in front of me. What do you get when you do that? So this is our t star because t star means it's positive negative. I think it's easier to do that in the calculator, but there's a lot of stuff that I just haven't had time to spend on yet with the calculator. Questions on anything with that worksheet? For that problem? So it's a 95% confidence interval, which means there's this much in each tail, so you're writing like the tail area right there. All right, I want you to go to, yeah. Second distribution. Oh, is that what you're asking?
Oh, I was asking what your.
Oh, all those are made in that chair right there. Was that the other thing you didn't have? Was that?
It was something.
I knew it was something dealing with that. Yeah, just grab any one of those that are sitting in that chair. Hey, the other sheet that I gave you, if you will look at that really quick. Hey, I want you to very briefly look at this and tell me something you see that should be confusing or red flag. Normal probability plot. This is something that we mentioned back in chapter 3 when we dealt with it. That I said, here's an option of what you can do, but I don't like doing it because I am not good at doing one very quickly. I would rather do a histogram. What do we check? Why do we check the histogram of residuals? For normal. How do we check a histogram of residuals for normal? No strong skew, no extreme outliers. So this one is checking normal. Using a what kind of graph? Using a normal probability plot. And you should be able to look at this one and kind of remember, how do I tell if it looks normal? What do you see in this? What do you kind of see there? If it is linear in a normal probability plot, that means normal. I don't ever need you to make one of these, but I need you to know if I give you this and you didn't have to check it, you would say, I'm checking this, or because of this graph, this graph is fairly normal, which means the data is what? This graph is fairly linear, so the data is approximately normal. And that's the one that, like, so if I gave you that instead of giving you a histogram, you would just have to know that that's what you said. Questions on that? And if you go to second stat plot really quick, like you don't have to have anything in there, I don't care. But if you go to second stat plot, the very last graph option you have looks kind of like a scatter plot. That's the normal probability plot. So it could do this for you if you wanted it, or if you needed to look at it for some reason. But that's where you would go if you chose to do this, but you don't need to do anything with that. All right, my last thing that I need to talk about is a Google form that I posted today. So a couple things. This one is stuff from the school, but there's one thing that's really important. This one is student information letter. I don't know what it is, but I'm sure you can click on it and look at it. You've probably seen it somewhere. This one is your late arrival thing that I talked about. Make sure that you do that. I know it's just a link, so if you get back in this Google form and go to the link again if you need to, just don't submit a second form. It says it must be completed by a parent or guardian. I don't know what information the Google form asks, but I'm giving you the information. And then it says that they're due by April 24th, so obviously they copied and pasted it from an old year because Wednesday is not April 24th. Go ahead and do that soon, though, so that we don't have issues, like, very soon. And then this last question is, so I always do review on the morning of the exam. So, like, you don't have to come to school, and I think I've talked about this in some of my classes. You don't have to come to school. But if in any time between 8:30 and noon, you want to come to school and come in here, you are more than welcome to. And I usually have a decent amount of people that do. I do not need anything definite from you. But administration is telling me that it is more important for me to go sit and babysit somebody else's class than to help you guys out. And I am very unhappy about it, and I would like to know what I'm dealing with before I go talk to them. So I'm just trying to get an idea of who all would show up. If I go across a big issue about this and like 3 people show up that day, then I'm not gonna feel real good about what I did. So I'm just trying to get an idea, like if you don't think you're gonna show up, then just tell me you don't think you're gonna do it. Some of you, so I said, yes, I'm interested. I'm not sure, but leaning towards yes, not sure, leaning towards no or no. I don't care what your answer is. I don't care if you come or not. I just want to get an idea so I know what I'm dealing with so that I can make accommodations to be able to do this. So the form itself should not take very long, but I just wanted to make sure I explained what I meant by all that and where it is.